recording today, so I didn't get with my earlier classes. So you'll notice on the front, you have 4 vocabulary words. I only have 2. We're only going to do the 2 that I have here on my notes. So we're not doing quantity and variable, so you don't have to worry about them. So the first one we have here, an algebraic expression. Numbers and or variables, add, subtracted, multiplied, or divided. Numbers and or variables. So variables, if it's algebraic, variables are included. Okay. And if you want to put, plus, minus, times, divide, use the symbols for multiplication, division, and addition, subtraction. I'm okay with that. So algebraic expression includes algebraic symbols, includes variables. So a numeric expression would not. When we were doing all our simplifying last week, Thursday last week, those were all numeric expressions. None of them had variables involved in them. They're all numeric only. Okay, numbers added, subtracted, multiplied, or divided. So most of what we are doing today, or essentially all of what we are doing today, is we are writing algebraic expressions given a description, given words. We will also do some where we have the expressions and we want to write it out in words. A couple of things you want to keep in mind. Okay. So we look here first before we get started. When you have more than or less than, that means you're going to be doing it in the opposite direction. It's going to be the last thing followed by the first one, generally speaking. 32 more than, that means I start with X and I finish with 32. 58 less than a number Y. That means I start with Y, and what do? I take away 58. So when you see more than or less than, it's the second followed by the first. It generally means you reverse direction when you're writing them out. So when I have 32 more than a number, that means I'm going to be doing addition. I have X, and I'm going to have 32 more than that. So I'm going to have X plus 32. Could I have 32 plus X? Yeah, you can, but only because it's addition. If it's subtraction, order matters. Addition does not. Okay? Addition does not matter order. So I could have written 32 plus X, but really we want to follow the rules what we have. We're starting with X, and we have more than that, so it's 32 more than that. Start with X and add 32 then. On the next one, we have a number Y, 58 less than the number Y. What are we starting with? We're starting out with whatever Y is and taking 58 away from that. So we're going to have Y minus 58. Could I do this as 58 minus Y? No, order matters. With subtraction, it matters which one you do. Is 3 minus 2 the same thing as 2 minus 3? No, they're not the same thing. Subtraction order matters. So when you have 58 less than, that means you're starting with the second part and you're going to take 58 away from it. So when I have 12 less than the number P, that means I'm going to start with P and I'm going to take 12 away from that. P minus 12. Questions so far?
Do letters always have to be in front?
No, they don't. But generally speaking, that's the standard procedure. The only time they're not going to be in front, generally speaking, is we start with a number and we take away. So if I had, for example, if I had Y less than 58, I would do 58 minus Y. I would have to do that. Generally, as a rule, standard operating procedure, variables come first when you're adding or subtracting. Okay, that isn't always the case, but it's pretty close to the case. Okay. Writing expressions of multiplication and division. 8 times a number m. Now there's a few ways to write this. Okay. The most common way to do it in algebra is just write the two things I'm multiplying. If one of them is a variable, right next to it without anything next to it. 8m means 8 times m. Now I could, if I wanted to, do 8 dot m. I could if I wanted to. I don't particularly like dots for multiplication. It's a personal pet peeve on my part. It's not the end of the world, though. But generally speaking, what looks cleaner, what looks neater, 8m looks neater. The one thing you don't do if you're multiplying and you have a variable is use an x for multiplication. If you do that, if you did 8 times m, now that we have variables, that looks like 8xm, not 8 times m. Looks like I have two variables that I'm multiplying times 8, not one. It's confusing. So never use x when writing a variable expression for multiplication. Best thing to do is just slap the number right up against the variable. It's neat, it's clean, and it's the universal ham multiplying these two numbers. Okay. What does it mean when I have a quotient? Division. Quotient means division. Does it matter the order that I divide? Yeah, 2 divided by 3 is 2/3. 3 divided by 2 is 1.5. Okay, so would you rather have 2 pizzas shared by 3 people or 3 pizzas shared by 2 people? I like my pizza. Okay, so the quotient of a number y and 5 means that I'm going to have y divided by 5. Now, I have it first written here as I prefer to see it for algebraic work. Y divided by 5 written as a fraction. Generally, when you see it in the algebraic expression, you're using algebra, you're solving an algebraic problem. This is how you're going to see it. However, it would also be valid. If you did y divided by 5. I prefer it as a fraction because when we're solving equations, working with equations later, the fraction is what you're going to see more often than not. And understanding that that means division, not necessarily a fraction, but it means division, is an important thing to be able to understand. Okay. Questions? Okay, now we're going to get to doing more than one thing at a time. Instead of just adding or subtracting or multiplying, dividing, we're going to do a combination of things. So I have a couple of things going on here. I have 3 more than. What does it mean when I have 3 more than? What am I going to do? I'm going to add what? I'm going to add 3. Whatever I start with, I'm going to add 3. What am I adding 3 to? I'm adding 3 to twice a number x. How do you get twice something? What do you do to get twice something? No, not squaring it. You do what? Multiply. You multiply it by what? 2. You multiply it by 2 if I have twice something. If you have $10 and I have twice as much, I have $20 because I took 10 times 2. Okay. So twice a number means multiplying by 2. So I'm going to have 2 times x, and then I'm going to have plus 3. So 2 times x, 2x, plus 3. This is what we want to do. This is, like I said, standard way of writing an algebraic. Standard operating procedure, SOP. Now, the next one, 9 less than the quotient of 6 and a number v. So, once again, I have 2 parts. I'm going to start with 9 less than. So 9 less than means that I'm going to do what? I'm going to subtract 9. This means I'm going to subtract 9. And then I have the quotient of 6 and a number v. Quotient means what again? Dividing. Oh, you guys are doing so much better than second and fifth period. I mean, I'm still not getting full participation, but man, this is the second period is like I had like one kid that would answer anything, and I had like maybe 2 kids that answered in the fifth period. I have at least 3 answering today. Yeah. So we're improving as the day's going on. You're waking up. Okay, the quotient means division. 6 and a number b. Does order matter with division?
Yeah.
Yeah, so when you see a quotient of 2 things, it's always the first one divided by the second one. So I'm going to have 6 divided by v, and then I'm going to take 9 away from that. So I have 6 divided by, no, did that. I have them all grouped up, sorry about that. So I have 6 divided by v minus 9. Now I like this better than 6 divided by v minus 9. This just doesn't look clean. This is much cleaner, yes.
Could you still do that method though?
You couldn't, I wouldn't mark you wrong. But like I said, this is a lot cleaner. It's neater. It's a little straight up. I can tell right away what I'm doing, what I'm not doing. If you're trying to solve an algebraic equation, let's say I have this set equal to something and I want to solve for v. This is how you're going to see it when you're solving. So starting in the next chapter, when we start solving stuff, you're going to see it like this, not like this. That's kind of why I want you to get your mindset in that direction right now. Okay? If you did it this way with the division symbol, it's not the end of the world. I'm not going to mark you wrong on the test. But I want you to start thinking. I want you to start thinking about what's coming down the road. It's not just here. It's what you're going to see coming up. Okay? Does that make sense? Any questions so far? Pretty easy stuff, right? I hope. Okay. Using words for an expression. Okay, so in other words, what we're going to do now is we're actually going to go from the expression to the written words. What does this mean? So I have 3x, which means I have what? 3 times x. Okay, so is there any other way other than 3 times x that I could write this?
3x.
3 times the number x?
3.
No, it's not 3 squared. It's not the same thing. Yeah, 3 multiplied by x. What's another word for multiplication that we use often? Or that you will see often? Times, what else? There's another one I'm thinking of. Product. Product is the other one I'm thinking of. Okay. Now, any of those is good. Anything that indicates you're taking 3 times whatever x is. Any way to indicate that would be fine. There's lots of possible answers. It would all be good. I'm going to go 3 times a number x. And if you want to see it written neater, when I post my notes online later, it'll look neater because I'm going to use Mrs. Trixie's notes because she writes so much prettier than I can. And she was doing it this morning. And she writes so much prettier than I can.
Wait, the access your notes online, you can just go to your teacher website.
Yeah, actually, that's a good thing. After I get done doing here, I'll show you what I'm talking about with that. To make sure everybody knows. Because my algebra, my pre-calc class kids couldn't figure it out. I'm like, really? They're all juniors and seniors. They should know by now how to get online and do that. I'll make sure you guys know that. I'll show you. Thanks for asking. Okay. So the next one. Y plus 8.1. Okay. So 8.1 more than Y. Excellent. Other ideas, other options. What's a more technical term that we use for addition in math? You will often see in textbooks.
8.1 more than 1.
Yeah. Or I could do, what I'm thinking of is the sum. The sum of 8.y and an 8.1 and the number y. That's when you can use. Like I said, you see that in textbooks all the time. They love to use sum and product and quotient because those are all the big words, right? The difference, because those are all the big math words. Why should I use plus? Okay. Like I said, we have choices. We can do them all. So 8.1 more than a number y. And that's just what I have. That is not the only possible answer for this. Once again, if this was a test, that would get you full credit. So would 8.1 plus y or something like that. Just written out would be okay. So next one, 10d minus 6. How many things do I have going on here? How many operations am I doing? I've got two things going on here, right? What are my two things I've got going on? Subtraction and multiplication. So I kind of want to deal with those in two different ways. Now, I could do, there's all kinds of possible answers I could do. The one you've seen the most would be 6 less than something. That's the one we've seen the most of, right? 6 less than 10 times d, or the product of 10 and some number d, or something like that. That's what we've seen most in. Could I start with the 10d, 10 times d, and then, take 6 away from that? I could do that if I wanted to. So if I wanted to, I could go, okay, 10 times, there we go, times a number d minus 6. Does that make sense? So most of the ones we've done would have started 6 less than 10 times the number d. It is possible to do it the other way, to do the subtraction at the end. You just have to word it carefully. Either one would be okay. Like I said, there's more than one perfectly good answer for this question. So if this was a test question, there would be more than one perfectly good answer for doing this. Okay? Questions before we get to the last part? Okay, this last part is kind of involved. So writing a rule to describe a pattern, you're actually going to have to do this on one of your classwork ones. It's nearly the same thing as what we're going to do here, coming up with the rule portion down here at the bottom. Okay, it's nearly the same thing. So, tabletop and picture show the height of a house of cards depends upon the number of levels. So I believe you can see on your picture, maybe a little hard here because they're kind of small. So no matter what, no matter how good or how bad the individual is at making a house of cards, it's going to be at least how far off the floor? No, not 3.5. 24 inches. Why? Why is it minimum of 24 inches off the floor? Because that's what the table is. Even if you really suck at building a house of cards, and the best you can do is lay them out flat and say, okay, we're gonna camp out in the woods. We're just gonna lay down here because I can't build anything up standing upright. It's still gonna be 24 inches because that's how tall the table is. So it has a 24 inches minimum. That's where that plus 24 comes in. So my plus 24 is, that's the same every single time. It does not matter how big or small the house of cards is, I'm going to be at least 24 inches off the floor every single time. Okay. Now, when you're building the house of cards, how tall is one level of cards? 3.5 inches. Okay. So if it's 3.5 inches, if I have one level, I add 3.5. If it's 2, I add 3.5 and 3.5. If it's 3, I add 3.5 and 3.5, and so on and so on. When you add the same number over and over again, what are you doing? You're multiplying by that number. So if I were to build 2 levels, that's what this is here. The height of the cards times how many levels I have. So if I build 2 levels, I go 3.5 times 2. If you had $3.50 and your friend had $3.50 and you put them together, how many monies would you have? You'd have 7 monies, right? Okay. So 7 plus 24 would be what?
34.
Ooh, yay, I got answers. I'm already doing better than Mrs. Piercy on that. So at least I got somebody to answer. So if I have 3 levels, I do 3 times 3.5. If I got 7 there, add another 3.5, that's 10.5.
You get 34.5.
Yeah, add 10.5 to that, I get 34.5.
And then the last one is 42.
If I have 4 times 3.7, 3.5, well, 2 is 7, twice that's 14, 14 plus 24 is 48. 38, my bad, 38. 38. Oops, if I write it correctly. Okay. Now the rule is, if it's n levels high, I don't know how many levels, but I want to come up with a formula, so I just count my levels, plug it into the formula, which is essentially what I did here. I took these numbers here and just plugged them in. That's the only thing that changed. Everything else in the formula stayed the same. So my rule is I take how tall the cards are times how many levels of cards. 3.5 times the level. So 3.5 times n levels. N stands for how many levels I have. And then what do I add every time, no matter what? 24. 24 is my constant. It's always at least 24 inches off the ground. Always at least 24 inches off the ground. If I'm really good, it'll be taller than that. If I'm not, it won't be. Okay. Does that make sense? That's one of the things you're going to be doing in one of your homeworks, is writing a formula like this. Okay, now it says write the rule as an algebraic expression to finish the table. We did that. Now write the rule in words. How would I write that in words? 3.5n plus 24. How would I write that out in words? The 3.5n means that I'm doing what? Multiplying. So I would have something like 3.5 times a number n. And then what am I doing after that? Well, it would be the sum would be in front, would be that and 24. If I'm doing it this way, I would put plus 24. How tall would the tower be if I had 10 levels? If you're really, really awesome and could build one 10 levels high, I think 5 is the highest I've ever gotten.
59 inches.
It'd be 59 inches. How did you do it?
33.5 times 10 plus 20.
Excellent. That's exactly it. 3.5 times 10 plus 24. 3.5 times 10 is 35, plus 24 gives us 59. Somewhere in here. Okay, what would the rule look like if the cards were not 3.5 but 5 inches? What would your expression be if you had 5-inch tall cards instead of 3.5-inch tall cards? How would that change the expression? How would that change the rule? What would I do? What would it change to? Bingo. So I would take the 3.5, put 5 instead, so I'd have 5n plus 24. We got bigger cards, which may or may not be an advantage to writing it out. Okay. Questions? Okay.